Glee2 .NET backend work is done by way of commands and handlers. So in the olden days, and maybe even not so olden days, but before you came to Ackland Avenue, maybe you were told to avoid putting actual business logic in the controllers of an API in the MVC pattern, or avoid putting real business logic in the whatever it is that reacts directly to an API request. And that is very true. That's good. And what that may have led you to do is to extract that business logic out to maybe what you might call a service or something else, another class or another function, and just so that you've moved that logic to another place. And that's good. But imagine one controller or one class or one group of endpoints that um, has 10 different endpoints. Each one of those endpoints would need to have possibly 10 different services. And you'd have to inject those services into the controller if you're using classes, or you would have to have some way to have access to all of those services. And if you're doing good practices, you probably are going to be using dependency injection, which means you're going to have a lot of dependencies that you're injecting into into this class. So in um, in .NET, that would be a very, very fat constructor on a class with lots of dependencies being injected, and it would just get really messy and very also very difficult to test. So imagine trying to write unit tests for that controller only to test one endpoint. You would have to basically mock or do something with all of those extra controllers that you really, sorry, dependencies that you really don't need just for this one endpoint. So we try to solve that with command handlers, where each command handler has one thing to do. There's another reason why it's very useful. So we follow this pattern called CQRS, which is basically just um, it stands for command query responsibility segregation. And the idea basically is that you separate the reads from the writes. And in order to do that, in order to separate reads from writes, you would want to put the reads on a separate server, really, from the writes. And so what we do in order to accomplish that is we do all of our reads directly in the controller. So if you're working in a controller and you want to read something out of the database, then you just go directly to the database or directly to the repository, whatever you've got that you want to just start reading things. You can write raw SQL, or you can do link queries, or whatever you want to do. It almost doesn't matter as long as it's clean. Now, writes, on the other hand, should be done completely different, because writes are it's kind of like the most important part of any system is where it's making changes to a database, or it's actually writing things, making changes somewhere. So for any writes, then we want to do what's called dispatch those writes. So in our controllers, I'll show you this in just a moment. I just want to get you ready. In our controllers, we're going to basically take the the request that comes in, and we're going to formulate what we call a command. And then we're going to dispatch the command. From there, the controller's work is done. The controller doesn't care what happens next. You can return whatever you'd like to return. If you want to return an ID that was generated in the same controller, you can do that, or you can just return nothing. You can return an OK, whatever you want to return. It doesn't matter, as long as it doesn't depend on what the dispatch sends out. So let's go ahead and I'll show you what that means. So I'm going to go into our example employee controller. And you can see here that there are lots of different methods. I want to show you a read. So this is get one. This is a a method that is just going to get one employee, and it's going to get it, as you can see from the route, it's going to get it by its ID. We're parsing that ID using model binding in a wonderful ASP.NET feature, and we're just going to go and get that employee from the database using its ID, and then we're going to map it from its employee entity form to a response, which is just a simple POCO. We call it POCO, it's plain old C# object, POCO object, which is just basically a data transport object, or a DTO. It's going to map that, and it's going to return the response. See here, we're not dispatching anything, we're not doing anything special, and we don't have to extract this out to a separate place. It really is fine to just go straight to the repository and get the stuff and return it. Now, on the other hand, sorry, I'll show you one more. This is another example of a get. This one is getting many, and we're doing paging, and we want to make sure that we're paging correctly and skipping and taking and things like that. So we're doing all of that here. We're getting we're getting from the parameters, we're getting the page size and the page number, and we're also getting like where let's see. Yeah, this is trying to get the search parameters, and it's going to pass those search parameters into the repository. And I'm kind of going fast, but you can look at this a little bit. You can look at this later on your own. The main idea is once it gets the paged results, it's going to map them from a list of employees to a list of employee responses, which you've already seen, and it returns it. That's it. Now, let's look at a put. This is a put. This put is going to change the name. So the route is the ID, and we're going to change just the name. And so here we're getting the ID from the route, and then we're getting the actual content of the request from the body. Now this update employee request is yet another POCO. It's being reused, so it's got a lot of different things on it that can be changed. But we're in this method itself, we're actually only going to use 4 of those properties. Now, this try catch that is here, it's not always necessary. In fact, in this case, I don't think it's really necessary. It's probably left here for just debugging purposes. It doesn't hurt that it's here, but it doesn't really do anything either, because exception handling will catch whatever comes from this. So this is actually the main thing I want you to notice, and I will go ahead and remove this just because I want you to be able to focus just on the main thing here that matters, which is this command dispatcher. Okay, so change names is just going to call this command dispatcher, which is something that we injected into the constructor at the top. I'll show you that real quick. So in this controller, we only have 4 things that we're injecting. We've got an identity generator, we've got a mapper, we've got a repository, and then we've got the command dispatcher. So then we'll scroll back down to the names, change names. So here you can see that we are taking the request, just like I said, we're taking the request and we're formulating a command. And then we are dispatching the command. That's it. From here, the controller doesn't care what happens next. There's no way for the controller to know about what happens next. This dispatch doesn't return any kind of feedback. There's no way for the controller to know what happened. And that's by design. And I can get into that more later on. But it is important to await this dispatch, because if you don't, it will go ahead and fire it, and it will go ahead and dispatch the command, and it will process it. But if for some reason it takes more than just a couple seconds to finish processing, then it could the thread that it's in, it actually could get garbage collected, and the thread would die, and then your process would stop. It may throw some exceptions, or it may just die quietly, and you may never know that it died. So so it is important to make sure that these methods are async tasks, and that they are awaiting the dispatch. But this is basically it as far as what the controller has to do. It's really just creating a command, dispatching the command. Let me show you this command real quick. Not much to it. We do want some sort of setter that's not accessible from normal code. This protected set makes it to where we can actually we can create fake objects, fake versions of this. We can mock it, things like that. And same thing with this protected constructor. It's not accessible publicly, but it can be accessed through different tools that use inheritance. So here we're using the typical encapsulation style, so that we're passing in its properties, it sets the properties, and then the properties are available for getting publicly. So this is just a POCO object, plain old C# object. But when you dispatch it, this plain old C# object, change employee names, does something special. So the dispatch method is something that lives in one of our Ackland Avenue libraries called commands, and acklandavenue.commands. If you ever want to look at it, it's in GitHub. You could just search GitHub for acklandavenue.commands, and you'll be able to find the source code for it. You may also be able to F12 into it, sort of, maybe not. Maybe you won't be able to F12 into it because it's just the interface. Let me see if I can control F12 into it. No, I can't. So you may have to go to GitHub to see the source control, or sorry, source code for this. It is interesting, but not super complicated. Basically, all it's going to do is it's going to take the type of the command that you pass in this case, which is a change employee names, and it's going to go out into what's called the app domain, and it's going to try to find a handler that matches that. How does it know that it has found a handler that matches this? Well, let's take a look at our domain project. The domain is where the commands actually live. So here you can see that there are several commands: remove employee, create employee, change employee tags. You can see there's a common thread. All of these commands are making changes. That is one way of spotting business logic. Business logic at its core is making some sort of change or effect on the business. So if you see something that is making change to the database, you have found business logic. And these commands, each one of these carries with it enough instructions to be able to carry out the task. Change employee display name. We need the ID and we need the display name. Change employee names. We need the ID and we need the names. Change employee personal email. We need the ID and the personal email. You can see what's going on here. Each one of these commands carries with it enough information to carry out the task at hand. This is create employee. It carries lots of properties, all the properties that it needs to actually create the employee in the first place. Remove employee. It only needs the ID. That's all it needs to be able to remove the ID, or to remove the employee. So you see what's going on. All right, now I was asking the question earlier, how does the dispatcher know what handler to use? So let's go into the handlers folder. Now you can see that here there's there is a one-to-one relationship with commands and handlers. So let's take the one that we were looking at before, the names changer, or the names updater. So I'm going to go into this class. All right, this is the magic right here. This class implements command handler of type, pay attention here, change employee names. That's our command. By virtue of having this interface on this class, the dispatcher knows, by scanning the entire app domain, all of the assemblies that it has at its disposal, it's going to scan all of that and find this class that implements this interface with this command. And so the name of this, it could be sea monkey. It could be anything. It could be apple tart. It doesn't matter. As long as it has this interface on it, the dispatcher will know that this is the right handler to use. Now, don't don't take me literally there as far as the name doesn't matter. The name really does matter. It matters to developers, matters to your future developers that are going to be working in this code base. So the name really does it does matter. We need to make sure that the name here expresses what its purpose in life is. And the purpose in life for this handler is to update the employee names. So it's called the employee names updater. You can use the word changer if you want to. A lot of these are they use the word changer also, so that's fine too. Either way, it communicates what it needs to communicate. Now, remember how before I said how when you're doing a bunch of services, you've got to inject all those services into the controller that you may or may not need for every endpoint, and it ends up becoming a big problem. Now, look at how small this handler is. I mean, we're looking at uh, 13 lines of code. Maybe not even that if you take some of the if you don't count the curly braces. It's just not much. We're not having to, it's very easy to read it. We're not having to dig through a bunch of code to try to understand it. It's very easily testable. It's only got one dependency that it's injecting here. It's just very easy. And it has one method on it that's called handle, one public method anyway. If you needed, you could create several private methods to help accomplish your task. But in this case, it's very simple. We don't need a lot. So the handle method takes in the command that we dispatched previously. That's because the iCommand handler, if you look at it, it has, uh, I'll have to go into the handler. Yeah, it has a handle method on it that takes in the type of command. So that's how that works. Let's get back to my handler. There we go. So I've got the command, and then I'm going to be able to use it. So here I'm already using the ID to get the employee. Then on the employee, I'm going to call change names, and I'm going to pass in again from the command. Remember, the command carries with it all the information that it needs to carry out its task. So it's going to use the first name, middle name, last name, second last name, and it's going to change those names. And then it is simply going to update the employee in the database. It pulls the employee out, it makes the changes, it puts the employee back in. That's it. That is almost every time the task of a command handler. Get something out of the database, do something with it, put it back into the database. That's the whole purpose in life. So let's take a look here at a few more of these. You can start to see a pattern here. Pull it out, do something with it, put it back. Pull it out, do something with it, put it back. Pull it out, do something with it, put it back. So it's really that's how simple your command handlers should be. Is just getting something out of the database, doing something to it or with it, and then putting it back into the database. Here you can see this is not pulling it out of the database because we're actually creating it. We're using the constructor of the employee to form the employee, and then we're going to use the create method and actually create it. So this is just an exception to that. Most of the time it's pull it down, do something with it, put it back. But in this case, it's create it and put it in the database. But you can see these handlers are very simple, and if you have to get out of this pattern of pull it down, do something with it, put it back, then you may be experiencing a code smell, or you may not. It should be that kind of deviation from the norm should be born out of a conversation with your team, just to make sure that you're doing the right thing. But these handlers should not be just riddled with a lot of things. Now, I'll give you one example of a way that you could actually have a little bit more going on in this. So let's say that well, we do have this situation. We've got employee address changer, name changer, personal email, phone number. And all of them are using the exact same dependency, the same writable repository. So let's just say that for fun, we'll do this right here. I'm going to remove that. And I'm going to go over here to the names updater because they're both names. And I'll put this over here. And then I'll go back over here and grab this interface. And I'll go ahead and just delete this file because I'm not going to need this anymore. Yep. And then names updater. And now I'm going to implement this interface. All right. So now I've basically added two handle methods to the same class, implementing this interface 2 times with 2 different commands on it. This is actually valid. This is fine. If this is something that you'd like to do, this is totally fine. And you might even find some other ways to reuse the code here and be able to reduce the lines of code or just improve things in some way. You can see here I'm having to go and refactor this just a little bit because now it doesn't know what this is. So I'm just going to say an employee name updater, and that'll fix this test. Yeah. So this is valid. Now, this is a small deviation from the norm because you normally you would only have one handle method in each class. But in this case, if this is born out of a conversation with your team and you all are in agreement that this really does make sense to put together, very similar logic, or it's not just because it's the same dependencies, but if they really are using the same dependencies and it's a very similar logic, there may be some other things you want to reuse between them just to cut down on code duplication. Then this is actually a really good solution. It could cut down on several things, like you might be able to reuse some context in your unit tests, or who knows. But the idea here is that you will end up having at least a one-to-one relationship with a handle method and your commands. So I hope this has helped, and we'll see you next time.